Right, guys, as we are pushing to our final examination. And mind you, we want you to bring that distinction home. We want you to bring that distinction home. So from now on my videos, I'm gonna be shortly trying to address few things that you need to pay attention to, trying to assist each other. Now on question number 3, where we took looking at the physical properties in paper 2. So then now, what is it that you need to know as a learner? 1, you need to be able to define what we call boiling point, right? The temperature at which or whereby the what? The vapor pressure of any substance or liquid, it's equals to the atmospheric pressure. Melting point, temperature whereby both the solid and the liquid are at equilibrium. Vapor pressure, pressure exerted by the vapor with its liquid in a closed system. Relationship, both boiling point and melting point, they're inversely proportional to vapor pressure, meaning a compound that has a higher boiling point, automatically it has a higher melting point and a lower vapor pressure. Any compound with a higher vapor pressure, automatically it has a lower boiling point and melting point. From melting point, boiling point, vapor pressure, you must relate those three to the strength of the intermolecular forces, as well as what? As well as energy. A compound with higher boiling point has a higher melting point, I said that. It has a lower vapor pressure. It has strong intermolecular forces. Stronger the intermolecular forces, the more the energy required to overcome those. Any molecular compound with a lower boiling point, lower melting point, and higher vapor pressure, it has weak intermolecular forces. The weaker the intermolecular forces, the less the amount of energy required to overcome those intermolecular forces. Then again, as a learner, you must know that we are addressing 3 types of intermolecular forces. The rest we discussed them in grade 11, the ion dipole forces, the induced dipole forces, the London forces, and blah, 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 blah. Those ones we address them in grade 11. So here in grade 12, 1, you pay attention to London forces, which are the induced dipole forces. That's another name. Secondly, you pay attention to what dipole forces. Thirdly, you pay attention to what we call hydrogen bonds. So then now, the strength among those ones. London forces are the weakest intermolecular forces compared to the 3. Hydrogen bonds are the strongest intermolecular forces out of the 3. Meaning a compound that contains London forces, it has a lower boiling point, melting point, and a higher vapor pressure. And a compound with hydrogen bonds, this one has a higher boiling point, higher melting point, and a lower vapor pressure. Comparing a compound that has hydrogen bonds with that one that has dipole forces, the one with the hydrogen bonds has what? The one with hydrogen bonds require more energy than the one with dipole forces, because hydrogen bonds are stronger than what? Are stronger than dipole forces. So then now again, you as a learner, you must be able to categorize all the different homologous series discussed in question 2 categorize them into these three types of intermolecular forces. So what I can say to you, take the first three A's. All those first three A's, they contain what we call London forces. We're talking of alkanes, alkane, and alkanes. Any compound that is an alkane, alkane, and alkanes, those ones, they contain what? London forces, which are the what? Which are the weakest intermolecular forces. Secondly, you take alcohols and carboxylic acid. Alcohol and carboxylic acid, those ones, they contain the strongest intermolecular forces, which are the what? Which are the hydrogen haloalkane haloalkane, they contain dipole forces. Then alkanes, they contain London forces. You shouldn't confuse the two. Meaning a compound with dipole forces, which is a haloalkane, is what? It has a higher boiling point compared to a compound which is an alkane with London forces. So haloalkane, they contain what we call dipole forces. Aldehydes contain dipole forces. Ketones contain dipole forces. Esters contain what? Dipole forces. So you must be able to categorize those homologous series in line with the what? In line with the what? In line with the intermolecular forces. How do you explain them? If you are comparing molecules that belong to the same homologous series, you start by the issue of addressing the structure. The structure, we are talking of the surface area and the what? And the chain length. That must be your starting point. From there, address the issue of the strength of the intermolecular forces. Bring along the comparison of the strength of the IMF in the involved compound. For example, if you are to compare butane with ethane, you can say that the particles of butane, they covers a larger surface area. So the larger the surface area, the stronger the what? The London forces. Therefore, more energy will be what? Will be required. But now if you're comparing molecules or compound that belongs to different homologous series, you don't address the issue of structure. You address the issue of the type. You start with the type. What are the type of the intermolecular forces found in this compound? For example, if we can compare a compound that contain what? London forces with a compound with what? Dipole forces. For example, an alkane versus a haloalkane. Then we'll be saying this alkane contain London forces, while this haloalkane contain what? Dipole forces. That's the type of the IMF. Then from there, the strength of the IMF. Then we'll be saying London forces are weaker than dipole forces. So we can say dipole forces are stronger than what? London forces. Then the last part, the amount of energy. More energy is required to overcome the intermolecular forces in the haloalkane. Or less energy is required to overcome the intermolecular forces in the what? In the alkane. It's T, S, E. Same. It's S for structure or surface area or chain length. Then the type, the strength, the energy. Then the last part as I conclude. If you're comparing an alcohol with a carboxylic acid, those ones, they both contain what we call hydrogen bonds. Your comparison, the first part, talk about the type. Tell the examiner, tell the marker that you know that both the carboxylic acid and the alcohol contain the same type of hydrogen bonds, which are the what of the same type of intermolecular forces, which are the what? The hydrogen bonds. Secondly, say something about the side, not side, S-I-T-E, the side. Tell the examiner or the marker that you as a learner, you understand that alcohols have one side for hydrogen bonding, while the carboxylic acid has two sides for what? For hydrogen bonding, the side. And then from there, the strength. Now you can say 2, it's better than 1. So you tell the examiner or the marker that the hydrogen bonds found in the carboxylic acid are stronger than those in the what? In the alcohol. From there, the energy. Therefore, if they are stronger, then it means more energy is required to overcome the what? The hydrogen bonds or the intermolecular process. So basically, this is a small summary based on your what? Based on your question 3. Thank you for watching. Continue to follow me for more as I push you, we push you to your final examination, getting that distinction.